Okay, so this video is going to cover both finishing the outer profile of the part, which is going to be very similar to doing the inner pocket, but then also we're going to include how to chamfer and go around this chamfer that I've modeled in as a contour. So here we go. I'm going to go through this one relatively quickly. 2D pocket, still using that same flat 3/8 inch end mill. Now in terms of the geometry here, we are going to select this outer line here, around, passes, finishing passes on. I'm going to have number of finishing passes, sure, at 1 right now. Repeat the finishing pass, finishing overlap of 0.1. Go beyond. I am not going to leave any stock now. And then let's see, what else do we have? Now, we'll see how this looks here. Okay, click OK. Oh, and then off of finishing, excuse me, in terms of passes here, instead of in computer, here's the critical thing, where. Select where, click OK. All right, so we've got that. I can simulate again this whole thing, make sure that it looks good to me. Bounce around to here. Okay, that's finishing out the inside. Now we're finishing the outside. That went to full depth. Sure, why not? It's doing the floor there. And now it's coming in up against the wall in there. Hey, that looks good to me. Okay, now here we go. We had cleared that out around the outside here. Now we're going to want to come in and finish this chamfer in here. So here goes with this. So if you hadn't actually modeled this in yet, that's still okay here. It's going to be slightly different than doing this. But what I'm going to want to do is a 2D contour. Right, 2D contour. Now the tool is going to be different than what we used before. Flat 3/8 end mill. I'm going to come back into my demo library here. Now it's giving us a lot of other options with this contouring. We're going to want to select this 1/4 inch chamfer mill. Click OK. Alright, 1/4 inch chamfer mill. So we're going to notice here that this tool actually has a triangular profile here. That creates a chamfer. It's considered a form tool. Alright, so 5,000 RPM spindle speed. We could actually change that up to 6,000 if we want. It's not going to harm anything. And then geometry here. So here's going to be the critical thing. We don't want to select this upper contour edge. It's actually going to be this bottom contour right here. So select that for our geometry. If you didn't do this correctly, notice that we have this red arrow selection here. If I didn't mention this in previous videos, but if you'd seen this in previous videos, if you click on this, you can actually change the side of the cut to the opposite side of that contour. That right there is actually not what we want. Where it defaulted to is correct. You can imagine here, what it's telling the computer to do is try and calculate this toolpath with the cutter to the opposite side of this contour, which would actually come in and gouge along and not give us what we want. So here we want it, the tool is going to be to the inside to where this pocket is. It's going that way around, left of the part, which is called climb milling. Get to that in some other video at some point. But now what I've jumped over here to is heights here. So since we actually already modeled in our chamfer, that bottom height is just fine. Passes here though, you can see now that it is actually selected chamfering operation. So it says sharp corners, select the sharp corner and define the size of the chamfer. Chamfered edges, select the bottom edge of the chamfer. So I'm doing what it's told me to do. So select the bottom edge of the chamfer width is calculated automatically. Fantastic. So that's the benefit of actually modeling your chamfers in on the parts if you want. But contours and chamfering is kind of the only thing where you could actually get a feature onto your part that isn't actually modeled. And we can show that maybe at a later date. But so I don't need to change anything here. But the only other thing I might recommend doing is the chamfer tip offset. Well, actually is added to the toolpath depth while keeping the tool in contact with the selected edge by adjusting the toolpath radial offset. So this might be a good idea to alter slightly here, just to make sure that the tool isn't full up against the edge. Click OK. So this toolpath generated, we have the chamfer mill walking around the contour, and here you can see because of that offset, it's actually moved this inward slightly. If we were to simulate right now, step through all these operations. It's coming around the outside. There we go. We are chamfering around and removing the material from there. Again, with that in mind, if we close that out, if we come back in and edit this, let's see how this makes the change here. If we were to change that back to a 0 right now, it's showing that the actual center point of this tool is coming down right here. That may cause some gouges, so that's why I'm recommending that we come back in here. So keep that line imagined there. If you chamfer tip offset here by just a couple, 25 thousandths or something, it's going to make it so that it has to come over and down a little bit. So if there's some slight mismatch, and again, you need to have some experience to see how this is going to make a difference, but that's recommended there. So we're actually going to be cutting more up in there, more along that face of the tool as opposed to right on the tip right there. So that is creating the chamfer all the way around. It's pretty cool. The other thing too on this one, for quality's sake, when we do passes here, so single, we've got that there, multiple finishing passes. I've got it set to finishing overlap of 0. Again, you may want to change that to actually be slightly larger value. So it's actually, if you can recall what it looked like before, the entry and the exit occurred at the same point before, but now it's actually entering from here, or entering from this side right here, coming around, and then actually traveling beyond that point and then coming out back here, which can give you a better surface finish on the actual part.